to demonstrate Bernoulli's theorem with simple illustrations. Hello students, today we will do a simple experiment related to Bernoulli's theorem.
What is Bernoulli's theorem, ma'am?
Bernoulli's theorem can be expressed with the Bernoulli's equation, which we have discussed in the previous class. P plus half rho v square plus rho gh is equal to constant. Let us prove this equation with the help of following theory. Theory: if a fluid is flowing in such a way that all its particles passing through a point follow same path, then this flow is called streamlined flow. Bernoulli's theorem states that the sum of pressure energy, kinetic energy, and potential energy per unit volume of an incompressible non-viscous fluid in streamlined flow remains constant. Mathematically, it is expressed as P plus half rho v square plus rho gh is equal to constant. Here, P is equal to pressure energy per unit volume. Half rho v square is equal to kinetic energy per unit volume. Rho gh is equal to potential energy per unit volume. For horizontal flow, P plus half rho v square is equal to constant. Therefore, if an ideal liquid is flowing horizontally in streamlined flow, then on increasing velocity, the pressure of liquid decreases and vice versa. Our aim is to demonstrate Bernoulli's theorem with simple illustrations. The materials required are 2 simple pendulums made of threads and light balls, clamp and stand, a rubber tube attached to glass tube with narrow jet, air blower, ping pong ball. Procedure: there are 2 situations which can demonstrate this theorem. The first is bobs of the pendulum moves closer to each other on blowing. Take 2 simple pendulums A and B made of thread and light-weight small balls. Suspend these pendulums from the horizontal rod attached to the stand. Keep the bobs close to each other at the same height, but they should not touch each other. Blow air between 2 bobs and observe them. Observations: it is observed that the bobs move closer to each other. The second situation is ball supported by an air jet. Take a glass tube with narrow jet and place a ping pong ball on the neck of the tube. Blow air down the rubber tube and observe it. Observation: it is observed that the ping pong ball is suspended in the air by the air flow. Inference: when air is blown between the bobs of the pendulums, the pressure of air decreases. Due to pressure difference on both sides of the ball, they move closer, that is, move towards lesser pressure region. When air is blown through glass tube, the air comes out through narrow jet at a high speed and therefore pressure of air decreases. The higher pressure region surrounding it pushes the ping pong ball inward and therefore the ping pong ball remains suspended in the air. Result: when velocity of a fluid increases, its pressure decreases and vice versa. Thus the Bernoulli's theorem is verified. Precautions: the following points need to keep in mind when the fluid should be incompressible and non-viscous. There should be no leakage of fluid in the tube. The space between 2 bobs should be small. The bobs should not touch each other. The bobs should be at same height. Sources of error: the following errors may occur while doing this experiment. The fluid may not be incompressible and non-viscous. The bobs of the pendulum may not lie at the same height.
Thank you, ma'am.